Hello guys, in today's video we are going to learn about RIP routing protocol, how it works. And we know that RIP is a category of distance vector routing protocol, and actually we are having three different categories in routing protocol. One, it is distance vector routing protocol, the second one it is link state routing protocol, and the third one it is advanced distance vector, or also it is called hybrid routing protocol. So today we are going to see about the distance vector routing protocol, how the RIP works. So actually the RIP, it works based how to tell that. Actually RIP, it does not have intelligence what EAGRP and OSPF has. Here there is no concept of neighbor discovery. So what it is actually neighbor discovery? RIP, it is a dynamic routing protocol. Everyone will accept to that. But what EAGRP and OSPF can do that RIP cannot do. In EAGRP and OSPF also a dynamic routing protocol, but they can identify their neighbors dynamically without having any manual interruption, or dynamically they can find their neighbor, who is their neighbor. For example, if I have router 1 and router 2 and connected using some links, or two interfaces of the router, and if I started running the OSPF as a routing protocol, EGRP as a routing protocol, and both the interfaces of the two different routers, then they will start speaking that language, EAGRP language or OSPF language, using the multicast address. So like that they will understand whether the router, if I am a router 1, I will understand router 2 is also I am running AGRP on the interface XYZ, and ABC router 2 is also having the EAGRP, and he is running EAGRP on the interface ABC. Just a minute, I will give you a clear picture. For example, this is my router, and again this is my router. Let's consider this router 1, and it is going to be router 2. Okay, these two routers are connected using some links. Okay, I'm running, for example, EAGRP or OSPF in both the routers. Okay, and I'm advertising that on on these interfaces. If I'm running OSPF on router 1, I'll run OSPF on router 2. If I'm running EJP on router 1, if I'm the same thing, I will run EJP on router 2 also, and the same thing I'll make EJP or OSPF enable on these two interfaces. So these interface and these interface will start speaking in their own routing protocol, if it is EHRP or if it is OSPF. So they will understand, okay, we are doing same topology or same strategies, and they will check few things, and they will understand if it is matching, or if it is passing, they are good to form a neighbor relationships. Then you can go and see something called neighbor table. There you can see router 1 will be the neighbor of router 2, and router 2 will be the neighbor of router 1. So once they form a neighbor relationship, then they will exchange their routes what they have. But in drip it is not like that. For example, here on the same topology I will tell you, I have only router 1, router 2. I can enable RIP here, and I can enable RIP here. What it is going to do, just by default, every 30 seconds it is going to send the route updates whatever it has. For example, this router, yeah, router 1, it has 100 routes, 100 different routes of different networks, 100 routes. And for example, this guy router 2 has 150 routes. These routes need to get exchanged. Okay, so if it is running OSPF EAGRP, before exchanging these routes they will form something called neighbor relationships. Okay, but in RIP it is not like that. If you're running RIP, I'm running RIP, I'm blindly going to send start sending my RIP updates on each interfaces where I have advertised my routes. I am ready to send my all the routing updates whatever I have in my routing table. So that's what RIP is going to do. It is not going to identify, okay, router 2 is my neighbor or router X is going to be a neighbor. It is not going to do that stuff in, it is not going to do that. Okay, it is not, RIP does not have that visibility to identify its neighbors. Fine. And how the RIP it will work? For example, in this topology, uh, 10.0.0.5, for example, it is going to be my source, and this 20.0, this is going to be loopback interface of router 3. Okay, if it is a destination, I can reach from source, that is 10 network, to the 20 network. Everywhere I'm using /8. So if I want to reach from 10 to 20, I have 3 different available paths where I can reach this 20. So how, which path RIP will choose? So here the metric is set to be hop count. So distance vector metric is set to be hop count. So whatever I have less hop count, that is going to be considered as a best path in distance vector routing protocol. So how does it works? Everywhere I have assigned the IP addresses. Only I'm going to do RIP configuration. You can see what all the IP addresses and what I have configured here. You can able to see those things. Okay. Fine. I'll show you here. Show IP interface brief. Okay. Configure terminal interface gigabit 0/2. No shutdown. Already configured. Actually, I have admin down due to before that I have practiced some labs. 0/1. No shutdown. I'll just make it up. What happened? Okay, sorry, it is serial. Interface serial 0/0/0. No shutdown. Fine. Now I made it up. So you can see the IP address ranges what I have used it here. Show IP and brief. Actually, I have 4 different networks which is connected to this router. You can see one it is 10 network, 11 network, 14 network, 16 network. So if you go and see the routing table, show IP route, I have all connected and locally present IPs and networks. This router know only about the network what it has. It does not know about the network what other router has. For example, in router 0 I have 4 networks, 4 different networks, and in router 5 again I have 4 different networks, but router 0 has no visibility about the routes what router 3 has. Why? Because I don't have any routing protocol running in any of the routers. Okay, so what we need to do so that these routers will come to know their routes. So we need to start running any of the routing protocol in these routers. Under these routing protocols, we need to advertise what are the networks we need, so that this advertisement will be going to the router, and the receiving router will know how to reach the particular network. I think I am making you confused. Let's go and see that how it works. So let's go to router 0. Okay, now I'm going to configure RIP. Configure terminal. So I'm going to do router RIP. Again, in RIP there are 2 versions, version 1 and version 2. Version 1 does not support any class. It supports only classful routing protocol, and I think you're aware of what is classful routing protocol and classless routing protocol. If I did not do any subnetting, that means I am just using just a classful IP addresses in my network. You are good to go with the version 1. If you are doing some subnetting and you don't want to you this then you should go for version 2. Why? Because version 1 does not support the classless routing protocol. Here simply I'm using version 1 because I'm using everywhere /8, which is classful routing protocol. So under this RIP, now we have enabled RIP under router 0. Now I'm going to start advertise the network what I has. Only I'm going to advertise the network what I have. I can't advertise the network what I doesn't have. Why? Because the router can't advertise that network. Only it can advertise what it has. Why? How it is happening? Before start enabling RIP, we can see something called routing table. Okay, routing table. I don't have any routing protocol, but there are few stuffs sitting in my routing table. How it is possible? Because it can identify the network what it has on its interfaces. It can identify and it can put it into the routing table. You can see here 10 network is directly connected to gigabit 0/0, and 11 network is directly where it is here it is where 11 network is directly connected to gigabit 0/1. Okay, and whenever I start advertising the networks, it is going to check on this routing table. Okay, whatever the network I am mentioning under RIP, it should present in this routing table. If that network it is not present in this routing table, then it will not be advertised. Okay, for example, I will show you here. I have the network 10 11 14 16 10 network. Okay, then 11, yeah, and 14 network 16. And also I am trying to advertise the network what I does not have in this router. Okay, but it will not advertise. I'm just for example I'm showing you something called 200 network. Okay, okay, still that the command is checking. Okay, but we'll never see about the 200 network. Why? Because we are giving some false information in the network, which is not good. Okay, you can now verify, show, run, see. So under this many networks I have advertised. Okay, let's go to the next router and we'll see enable show IP route. And RIP, every 30 seconds it is going to send its routing updates to its connected, we can't tell as a neighbor, a directly connected router we can say. Why? Because here it is not going to find its neighbor. It is just a router, just a link, that's it. So here I'm not having any RIP routes learned still. Why? Because I am not yet started running RIP on this router. Let's go and do that. Configure terminal, router RIP. Okay, I just enabled RIP. Just will go and see whether we got any routes. Show IP routes. Okay, still I will not receive the RIP updates. Why? Because we just enabled RIP in the router, but we did not enable on these interfaces. For example, when I started advertise these networks, okay, what this router has, my RIP update is going to flow on these interfaces. Now this router, I'm sorry, is going to receive the router 1 RIP updates on gigabit 0/0, which is having the IP of 11.0.0.1, and here 11.0.0.2. They are in the same subnet. That means they are in the same network. So my RIP route update, it can send updates, it can receive RIP updates. So there will not be any hassle in that. So that's what we should not. We also advertise the networks under the RIP, then only we will start receiving the RIP updates properly. Configure terminal, router RIP, network. I'm advertising now 11. Okay, now we will start receiving the route updates from router 0 through RIP. I still not yet advertised 12. Okay, let's wait and watch. This command is more than enough to receive the RIP route updates from router 0. It will take 30 seconds. Every 30 seconds it will send the updates. See here, in last I show IP route command, I didn't see any RIP route updates, but in the here you can able to see here this 10 network, 14 network, 16 network, which is directly connected to the router 0, and router 0 I am running RIP. Under RIP I am advertising these networks, so that advertisement is reach router 1. Now it is looking that updates are pushed to router 1's routing table, that is forwarding table. So I can see those network routes under this routing table, which is learn via or is nothing but a RIP. So like this I will enable RIP in all these routers. I'm just enabling. Okay, and one more thing I want to show you here. See here, you can able to view from router 0. You can see 10 network, 11 network, oh sorry, uh, 14 network, 16 network, but you can't able to see the 200 network which we advertise, which is first of all not connected in the router 0. That command is still there, but that command is useless under RIP, which is called network 200.0.0.0. Why? Because we don't have any network which is directly connected to that router. Only you can able to advertise the network what you have on your own router. That means if I am the router, if I have 5 interfaces with 5 different networks, only I can able to start advertise those 5 networks. Apart from that I can't advertise it, so be clear in that. So here I will advertise 12 also, router RIP network 12.0.0.0. So in router 4 I have 2 networks, router RIP network 14.0.0.0 and network 15.0.0.0 exit. Okay, and in router 2 I have again 2 different network 12 and 13. I will enable RIP and I'll advertise it. That's it. Router RIP network, excuse me, 12 network 13 network I advertised. And in router 5 I need to advertise 2 more networks here, router RIP network 16.0.0.0 network 17.0.0.0. it is a class C network everywhere what I am using here for this demo. And in router 6 enable configure terminal network, sorry, router RIP network 17.0.0.0 network 18.0.0.0 exit. Again in router 7 I need to run router RIP and I need to advertise 2 networks here, which is which it has router RIP 18.0.0.0, oh sorry, under router RIP network 18.0.0.0 network 19.0.0.0. I'm left out with 1 router here. I don't have the interfaces to connect switch and 1 more PC, so that I'm going to create 20 network, so please apologize for that. Enable configure terminal, router everywhere I have done IP configurations, router RIP, so only I need to do the RIP configuration everywhere. This is the last router network one, it is 13.0.0.0 that, and next one it is I have 15.0.0.0 network 19.0.0.0. and here I have 1 more what is called 20, so I need to advertise even 20.0.0.0. show IP int brief. You can see that this is what loopback 0 I have created with 20.0.0.5. Now we started running grep in all these routers, and also we advertise what are the networks already we have which is connected on those particular routers. Now In beginning of this class, I have told something called in distance vector routing protocol. For example, RIP uses metric as a hop count. Here in this scenario, this 10.005 can reach this 20.005 in three different ways. Router 0, router 1, router 2, then router 3. This is one path. Then he can reach router 0, then router 4, then router 3. Then he can reach router 0 from router 5, then router 6, router 7, then router 3. So these three different available paths now available for the source router 0 to reach the destination, that is loopback IP 20005 of the router 3. So in this three path, which RIP is going to preferred? So let's go and verify it. All these RIP considers best hop counts. That means who is having the less hop counts is considered the best path. So in first path, from router 0 to router 1, one hop. Again from router 1 to router 2, second hop. From router 2 to router 3, third hop. So it needs 3 hop to reach the destination if it is taking the path option 1. If it is taking the middle path, okay, from router 0 to router 4, one hop. Router 4 to router 3, two hop. Okay, total two hops. So if it is taking the middle path, it is taking just only the two hops to reach the destination. If it is taking the bottom path, there are from router 0 to router 5 one hop, again router 5 to router 6 second hop, router 6 to router 7 third hop, and router 7 to router 3 it is a fourth hop. So top one having three hops, middle one having two hops, and the bottom one having four hops. So let's go and see. First we can able to ping 20.0.0.5. Yeah, I can able to ping. Okay, which path it is taking? Tracert 20.0.0.5. Here it is just taking three hops. Let's go and see which path it is. It is a default gateway of the PC, which is 10.0.0.1. From there it is going to 14 network. Okay, fine. So it is taking the middle path. Why? Because he is having only two hops to reach the destination. Then it is directly going to 20, which is our destination, which is directly connected on the router 3. Okay, fine. So what happens when something happen on this link? Let's think that something gone wrong on this link. Okay, let's go on this router interface gigabit 0/0. I'm just shutting this port down so that this router won't advertise about the 20 network to this router 0. Even he will not get the 20 network from router 3 to router 4. Why? Because this particular link is no more now. Correct? Okay. So again, let's go to that PC and start doing that trace. Now the path is different. See here, it is going to default gateway. From there it is going to the 11 network. It is not going to the 16 network. 11 network is here. Okay, it chosen the top path. Why? Because when compared to bottom path, top path is having less hop counts. In top path we are having only 1 2 3 hop counts. In bottom path we are having 1 2 3 4 hop counts. That's what. So if for example, if anything happen between these any of these circuits, okay, let's consider I'm going to this router, shutting interface gigabit 0/0 shutdown. I'm shutting this link. Okay, so there is now this this path is not valid to reach 20.0.0.5 from the source 10.0.0.5. Obviously it has to go via this path. So what, how many paths it is available? First it will see the in that which path is best path. It will be decided based on the hop counts. Let's go on trace route now. See, it is taking from there, it is going to 16, then 17 network, then 18 network, then it has to reach the 20 network. Okay, So this is how the rip will work. So again, small point. So rip metric is based on the hop count. And thanks for watching. If you like, please subscribe my channel and stay tuned for upcoming videos. Bye bye.